Go.
Hello, my dear students, and welcome to our second experiment examining the properties of water. Today we're going to look at 4 more properties of water, specifically its high heat of, not its high heat capacity, but its high heat of vaporization. We're going to look at the electrolysis of water, and we're going to look at the solvent properties of water. So, let me take my mask off so I can enunciate better and put on my safety glasses because we will be working with solvents, electric currents, and chemicals, including a few caustic or noxious chemicals. The first property of water I want to describe is the high heat of vaporization. And here, the protocol, if you look in your lab report, says to use a cotton applicator swab to draw 4 lines on the desktop of water propanol, ethanol, and methanol, and look to see and time how long it takes for them to evaporate. And you have to remember that water, and we'll discuss this when we go over the discussion and answer some of the questions in the lab report, water is polar and exhibits hydrogen bonding. So all the molecules are bound to each other. And they stick to each other, and it doesn't evaporate very fast. Plus, they adhere to each other, and it beads up. If I go ahead and maybe speed this process up, you don't know this, but I'm already speeding it up because I have a fan going in the background. But if you look here at the methanol, it has almost evaporated completely. And now it has. And then if you look next, you'll see the propanol and the ethanol. And the ethanol is a form of alcohol with 2 carbons. Methanol has 1 carbon, very volatile, low heat of vaporization, high vapor pressure, which actually makes it quite dangerous. This is related to the safety video we did earlier, where I made the green flame and discussed the kindergarten teacher in Texas who set her class of kindergartners on fire and sent 6 of them to the hospital. But obviously I can speed up the evaporation if I add a little, agitation of the air to it. And if you look, the ethanol is almost completely gone. And the propanol is still there. Ethanol is completely gone now. Propanol is still there. And the water line is still there. It's narrower, but it's still there. So the way in which they evaporate is methanol first, ethanol second, the propanol is gone now, and the water is still there because it has a much higher heat of vaporization. I need to add more energy to the system to evaporate it. You know this when you dry your hair. If you have a hair dryer and you add more energy to the system, you add enough energy to those water molecules for them to break the hydrogen bonds and escape and evaporate into the air. This is still here. It'll be here at the end of class. Let's go to our next property of water. We talked about capillary action. But this time, instead of putting a capillary into some water with some food dye in it, I put a piece of celery in there. And if you look at the very end of the celery stalk, you'll see that the dye made it all the way to the top. This isn't capillary action where it only rose as high as the column of water could be supported by the hydrogen bonds before the mass of the water became too great and the weight pulled it back down. It came all the way to the top. I've taken a few sections and sectioned some of the bit there to show you the transport vessels called xylem that carry water from the roots to every part of the plant. This is done by a process called transpiration, where water evaporates from the leaves, petals of flowers, stems, stomata in the leaves, and the water evaporates. And when a water molecule evaporates and leaves the flower, another one takes its place, and it's connected to every other water molecule all the way down to the root. It's an amazing process. And in these carnations, this is one that has been going for 2 days because I forgot to bring it in yesterday. But it was put in with some blue and red dye. I had the goal of making purple, bobcat purple flowers, but only the red dye was taken up by the flower. Very interesting. There's a science fair experiment in here somewhere. But my point is that I took a white carnation and was able to infuse the dye throughout the whole plant. Here is one my wife started last night, where this was just started last night, and you can see some of the flowers aren't taking up the dye, or to any great degree. The lower ones take it up more, and then the top ones even more. This has only been going a day with green dye. But again, this process of transpiration, transport of water by evaporation, the water molecules evaporate out from the plant, and the other water molecules are pulled up throughout the plant. Amazing that you can get water up to a leaf in a tree that's 100 feet tall, over 100 feet tall. You have some awfully big trees here in Arkansas, but the only place it gets its water is from the roots and the ground. And it does it by transport, by a process called transpiration. A little different than capillary action. Now let's look at electrolysis of water. This is, excuse me, station 3. And here we have electrolysis of water, where I'm not separating the water molecules, I'm separating the hydrogen and the oxygen within the water by putting 2 electrodes, and my electrodes in this case are pencil leads. We did say metals have the property of conducting electricity, and non-metals tend to be poor conductors, but actually graphite, pure carbon, is an excellent conductor. And I'm using the pencil lead. I've sharpened a pencil at both ends, and I've connected it to a 9-volt battery. And if you look, you can see the bubbles forming. And if you can zoom in, if you can't, we'll just have to take my word for it. There are twice as many bubbles coming from the negative pole. Can we get that one more toward the front? I don't know, maybe I can turn it a little. There we go. Nope, it's resisting me. But if you look at these fine bubbles coming off, you'll see that this one here, as I come over here, this one here is attached to the positive pole, and this one should be producing twice as many bubbles, and it's connected to the negative pole of the battery, making this the cathode where the reduction is occurring. We'll talk about oxidation reduction reactions later. But what I'm doing is splitting the water into hydrogen gas and oxygen gas simply by running a current through water. And to help conduct the current, I added an electrolyte, specifically sodium hydrogen carbonate, or what you know as baking soda, which is a good salt for acting as an electrolyte to carry the current. And our last part of this experiment is testing the solubility of 4 different substances. And those substances are sugar, sucrose, and I'll just put some in here, and I will stir it up to see if it dissolves. And if I stir vigorously and am patient, I think you'll see it dissolves. The next one is salt. I have plain old table salt, sodium chloride, and it is in this one right here. And if I put the salt in there, you know, it's cloudy for a second, but in a minute or 2, after it has a chance, it's kind of cold in here, so we'll get it going. You will see that it dissolves completely. The other one, I've already added some to it, but I'm going to add some more. And if I put the salt in there, you will see that it dissolves completely. is another salt, in this case calcium carbonate. We're going to discuss it in the discussion portion. But if you look, when I go to stir it up, perhaps at the beginning it looks like the others, but it stays like that, unlike these others that rapidly clear and dissolve. And then the last thing I want to test is whether or not this mineral oil, I just bought plain old Walmart brand mineral oil. We use it in woodworking as a finish on some woods and everything, but has other uses as a lubricant and medicine. And if I pour some of that in there, you will see that all it does what any oil does, which is just float on top of the water. I don't know if you can get that in there. It's got a big top of mineral oil, so all you can do is kind of see the mineral oil floating on top of the water, and none of it is dissolving. You know, I can kind of agitate it, and then those globules of oil just go back together and never dissolve in the water. So that concludes our experiment for today. We had 4 stations, and the students in the face-to-face classes worked through them, doing them themselves, experimenting with things, trying different combinations and playing. I wish y'all could play a little bit more, but we will discuss this. You'll see the lab reports are already posted. I'll get this video posted and post a discussion video hopefully tomorrow or the next day, so that you can see what's expected when you answer some of the questions in your lab report. So until then, goodbye now and stay safe.